Welcome to the Building a Math Community workshop. I'm Megan from the Math Workshop. I want to thank you for taking the time to consider how we can build a math community of learners. My hope is that we add to your toolbox of ideas and activities to support your mathematicians and help you set the stage for starting the school year on the right foot. Let's take care of a little housekeeping first. This workshop will be an hour and a half long. Within an email that you received that contained the link for this workshop recording, you should have also located a note-taking guide that you can use to take notes while you process the information in this video. This note-taking guide is aligned with this workshop. Feel free to do what works for you. Perhaps you want to digest this workshop in chunks, or maybe you want to rewatch it later. Additionally, you should have seen workshop gifts, which we will tell you about at the end of this workshop, and a certificate of completion. In that same email, you will have seen a SurveyMonkey link that we would greatly appreciate you considering to fill out for us at the conclusion of this workshop with feedback for us. Thank you in advance for considering and taking the time to do this. Here's our workshop agenda. We will go over the free resources that you received. We will share the 20 mini lessons to build a math community, and we will share your closing gifts. Let me take a moment to introduce myself if we haven't met. My name is Megan Brewer, and I'm the creator of the Math Workshop. We support a community of mathematicians who believe that learning math to the deepest levels is possible for everyone. At our core, we're committed to making mathematics learning fun and engaging while ensuring that all instruction centers on making sense of concepts. We provide the tools and resources for students of all ages, including hands-on manipulatives and visual aids that help unlock the connections and relationships between mathematical concepts. We believe that learning through investigations provides the framework for developing essential problem solving and critical thinking skills while promoting a growth mindset. I'm a former elementary school teacher. I was a math coach at a Title I K through 6 school. I worked for a large school district in the curriculum office where my job was to share research-based strategies with teachers in our districts to support multilingual students and help them to have access to grade level math standards and content. I've worked as an educational mathematics specialist consultant for several companies, traveling across the United States to coach teachers around mathematics instruction and teaching teachers math content courses and workshops, as well as I worked as a curriculum designer and editor. But now my favorite current roles are teaching students in my local community where I live and supporting educators and parents locally and across the world as they teach their children math. I currently live in North Carolina and I am a mom of 2 teenagers, and we have a lot of fur babies in our house. I love to travel and I'm a voracious reader. We were so excited to share 4 free resources with you to use with your students to help you build your math community. Let's take a few moments to go over the free resources and how you might use them with your young mathematicians. We shared 3 versions of the Find Someone Who activity. This is a great activity for students to begin to get to know each other, especially on the first day of school or the first week, or maybe when you're beginning a math group. Each student will need one of the handouts. Students will walk around the room and find other students that fit the criteria in each square on the handout and have those students write their names in the squares. Generally, we ask students to find one student per square. But you don't have to do that. Multiple students could sign in a square. Sometimes we say that they can only have another student write their name once in one of the squares, but of course, this depends on how many students you have in your class and what works best with your class. Most of the questions are related to self. For example, find someone who likes a same food as you so that both students get to know interesting facts about each other. There are three different versions included. The version on the far left of the screen would be perfect for kindergarten because, or for non-readers, or maybe students that are acquiring a new language of English, because they really just are identifying if they like the image in the picture. So you're finding someone who likes pizza or likes books or likes stickers. And the other two examples, of course, could be used with readers. Another gift that we sent you were partner pairing cards. We sent you 9 different sets of cards from 10 frames with numbers, ways to make 10, double sums to 20, base 10 block images with numbers, multiplication area models, 2 levels of geometry cards, fractions, and decimals. That's over 230 different cards. You can use these cards to quickly and randomly match up your students together for activities and assignments. You will want to grab the same number of cards that you have as the number of students in the class. And just so you know, each set has a trio set of cards at the end of each document that in case you have an odd number of students that day. So one of the partner pairings will, instead of being partners, will need to be a trio set, so no one is left out. You should have also received 8 sets of Rally Coach cards. Now, Rally Coach is a Kagan cooperative learning structure where students work in pairs to solve problems, with one student acting as the coach while the other student solves. And then they switch roles. This structure promotes collaboration, communication, and problem solving. You could use the partner pairing cards to pair up students randomly if you choose to. Then once pairs are created, each pair of students needs a set of rally cards. You would first model for students how to be in the coaching role and how to be the one who's explaining their thinking and reasoning. Partners take turns and switch roles. With the cards that you see on this slide, one version of this activity could be having student pairs place all the cards face down in a pile between them, and the first partner turns over 2 cards. And that partner compares the 2 cards, sharing out loud which number or image on the card is greater and how they know. The other partner coaches, praises, and asks questions. Then they switch roles, and the other partner turns over 2 cards, comparing what's on the cards, and again, sharing which one is greater and how they know. Another version of this activity is for the student to turn over 3 cards and talk through out loud how to order them from least to greatest. There are directions included with each of the Rally Coach card sets. You will see 10 frame cards, base 10 block cards, numeral cards, decimal grid cards, equivalent fractions, and decimal grid model cards, as well as percents. You also received the Mystery Person Investigation Unit. This is a community builder for the beginning of the school year. The investigation contains over 50 Google Slides, which involve daily mathematical investigations for students to engage with for the purpose of uncovering who the mystery person is in the class. There are 10 math investigations that your class can engage with, and all can be adjusted to fit your math standards. There are teacher tip slides at the very end of the slide deck, and they are for your eyes only. You can choose to do 5 investigations, 7 investigations, or do all 10 of them for 2 weeks. It's up to you. Your students will have a lot of fun trying to figure out who the mystery person in the class is. As the class reveals, well, you're going to reveal clues about the class data that's collected each day. Now, some of the investigations are collecting, graphing, and analyzing eye color, fingerprint type, measuring hand spans, investigating baskets made from throwing wadded up papers in a certain amount of time to a trash can. Let's pause for a moment and take a deeper dive just into one of the investigations from the Mystery Person Investigation Unit. So here's an opening slide. You would say, share with the class, someone in this class is a mystery person. You will become detectives and figure out at the end of the investigation through clues who the mystery person is. Good luck solving the mystery. Now, a secret that you're going to keep from the class is that when the class begins these investigations, not only does the class not know who the mystery person is, but honestly, you're not going to know either. But again, this is a secret. Don't tell your class about this. You want them to think that you know who the mystery person is from the beginning, but really, you're not going to know. Let me explain why. In reality, through the investigations, you will reveal clues about the mystery person. And most of the time, you're going to choose the data sets that contain the majority of your students. Let's look at one of the examples further so I can explain this. So here's one of the investigations you could do with your class one day. So it's investigate eye color. So you would put this slide up and ask your students, what is your eye color? You're going to collect their eye color data. You're going to have them graph their eye color data, analyze the data, and then you're going to reveal the clue the next day. Okay, so you could collect student eye color data on a graph similar to this one. You could give every student a little black and white eye, like the one by the title on the graph, or you could just give them a square slip of paper or a post-it note, and you could have them draw and color their eye. It's very important that you have them write their name, however, by their eye, however you're going to collect that data. And then you need to display the class data. So it could just be on a whiteboard, it could be on anything, it could be on chart paper, however you want to display it, but you're going to need each student's name by their data. So this is an example of just a small make-believe class set of data. Based on this sample, I would probably, in my mind, again, I'm not going to share this with the class, I would choose one of the students from the brown eye category. And the reason is because that is, for this small group, that's the majority or has the highest number of students. So the next day I would reveal the clue, oh, the mystery person has brown eyes. I would not choose green because then the class would already know it's Jane because Jane is the only student in that category. So hopefully that makes sense to you. Then you will see slides that have data discussion questions. So after the class has collected and displayed the data for that day, here are some possible data discussion questions you could use to facilitate a data discussion. What do you notice? What do you wonder? What does our data show? Which group has the most? Which has the least? Why? How do you know? What questions does our data make you think about? What do you want to find out next? So then you will find a slide that you can share the next day, and you will either type in or just verbally share, well, the mystery person has brown eye color, or whichever you decide, okay? And remember, we suggest you choose the largest group for the clue just to keep the students guessing. But after day one, you're going to have to somewhere on a mystery piece of paper or in your brain, you're going to have to start keeping track of who your possible people, your students can be. in your mystery person, because the next day, whatever the next investigation you choose to do is, you're going to have to make sure you're keeping still that brown-eyed person in mind or people in mind, and then choose the next clue. Hopefully that makes sense. That you've got to have it line up so that at the end of the time of the investigations, it just gets down to one person. After students learn a clue, you can ask them what they know so far, let them turn and talk or discuss in small groups the clues that they've uncovered so far. Here are some sentence frames that could support that discussion. I think the mystery person is blank because blank. I think the mystery person is not blank because blank. I agree with blank because blank. I disagree with blank because blank. So these could be used as scaffolds to support that discussion. I wouldn't share with students, though, who the mystery person is. I would just listen and just, you know, ask them for their reasoning and their justification. I wouldn't share who the mystery person is until we're ready to finish the investigations. So when you are ready to finish the investigations, here's a slide for the mystery person is. So here's a tip for you. If the mystery person is revealed early on through the clues, and it's just the way it is with your class and the data and just how it turns out, it's okay. And say you want to continue with more of the investigations, just tell the class they did a great job figuring out the first mystery person, and you're going to continue to be detectives, and there's going to be a second mystery person. So you can continue this, however it works out with your class and the clues. But I think you will have a lot of fun, and your students will be detectives, investigating, collecting data. So enjoy those investigations. All right, let's move on. Let's think about our why. Why building a math community? I love this quote. Building student engagement begins with community and relationships. Another quote. Our most challenging students will allow us to teach them if we connect with them first. I would expand this quote to including opportunities for students to connect with each other, as I believe they can learn a lot from each other. Here's a last quote. Building relationships with students is by far the most important thing a teacher can do. Without a solid foundation and relationships built on trust and respect, no quality learning will happen. That's our why. All right, let's start our 20 mini lessons to support and build a community of amazing mathematicians. Now, we're going to share with you these 20 mini lessons. They can be done in any order, and depending whether you are kindergarten or high school math, they can be tweaked or modified to fit the needs of your students. So as you watch the 20, as I explain them to you, think about, okay, does this work with my group? What am I thinking about this? How could I adapt this? Or is it good as is? Okay. And we recommend doing one mini lesson a day for the first month of school. So you're going to be teaching your math curriculum during your math block, if that's 60 minutes or 90 minutes or however much time you have, but then allow a little part of that class, or I guess it could be another part of the day, it doesn't have to be in math class, to do one of these mini lessons. And they should only take about 15 minutes. You can definitely expand them if you choose, but they were written and designed and created to be really short and sweet, but really impactful for supporting that, building that math community for the year. So here's the first one. We are a community. As a class, brainstorm a list of all the communities we belong to or could belong to. What are characteristics of a community? You could have students first do this independently and then share with a partner, or you could have students working in small groups, or you could keep it whole group if you wanted. You have lots of options on what works best for you and your students. You could consider creating a class chart of characteristics of a community to revisit during math class throughout the year. Your students might have on their brainstormed list of communities, could be a class in school, could be Boy Scouts, Girl Scouts, religious community, or maybe belonging to a YMCA, or an art club, or a karate studio, or a dance studio. It could be a neighborhood or an apartment building. There's so many different responses they might come up with. And as far as characteristics of a community, help your students generate a list of things like regular interaction, seeing each other often, friendly communication, strong social bonds, shared interests or activities, a sense of belonging, shared common goals or values. If your students struggle at first, maybe think of a community that you belong to now or when you were their age and share about it and the characteristics, and that might help your students. So that was our first mini lesson. We are a community. Here's our second one. Oh, we love this one. This one is about observing a successful turn and talk. This one is a really good one to do at the beginning of these mini lessons. So students are going to have the opportunity to observe a turn and talk fishbowl example and brainstorm afterward a list of criteria to keep alive, that they should remember to keep alive during a great turn and talk. So one idea could be have the teacher yourself and a student that you will ask beforehand and that you think would be successful modeling a turn and talk for the students to watch. So the fishbowl idea, if this is new to you, is so the teacher and that student that the teacher asked, would you feel comfortable modeling a turn and talk with me? Would be maybe in the center of wherever, it could be on the rug or in the classroom. And the rest of the class is going to be around. It could be standing because it's not going to take long. It's just going to be a few minutes. Or maybe they're seated around watching, but they're observing. So that's kind of the fishbowl model. Another idea for this fishbowl model could be have two students that you feel are comfortable and you ask beforehand to set them up for success, and they say yes, to model a turn and talk while other students and yourself are gathered around watching. And so the important part is after the observation, you have the whole class brainstorm a list of criteria that they observed in the modeling. For example, they might say things like, both speakers gave eye contact. They might say, both speakers were listening. They might say, both speakers shared their thinking. So the idea is that students had this model, this visual model of what a successful turn and talk looks like. Now we're going to watch a video example of a fishbowl model of a teacher and her student demonstrating for the class how to do a turn and talk. And then the teacher is going to ask the students who are observing to identify what was successful about the turn and talk. Now, our purpose in watching this video is to see how this could be done. So before the video starts, I want you to be thinking in your mind, what grade do you predict that this fishbowl model of a student with a teacher would be?
Data at the different names. I just want you to look at it for a minute and think about it. Okay? Look at this right here. Okay. Now, I'm wondering, we're going to do a turn and talk in a minute, but I'm wondering if maybe Irene, would you be willing to do a turn and talk role model with me? Yeah? Okay. So let's go over to the back area. Elijah, stay in your square, honey, but just spin your body. And Irene and I are gonna sit right here. Okay, stay in your squares. Okay. So what we're gonna talk about is, the question we're gonna talk about during our turn and talk is what we noticed when we put our names up on the chart. What did we notice? Do we think there's more students that are wearing shoelaces? Do we think there's more that are not? What do you notice about us? How are we sitting?
Applesauce.
Good. And now, so we're going to do a little conversation. I want you to watch us carefully to notice what we're doing and if you think it's a good turn and talk, if we're doing good work, and why, okay? So, hi, Irene.
Hi, this is Louise. Do you think that there's more on yes or no?
That's really tricky. I'm not sure.
They're really close.
They are close. I'm looking, and I do see a lot of names on yes. So a lot of students are wearing laces, but then there are some that are not wearing laces. What do you think, Irene?
I think that there's more on yes.
Why do you think maybe there's more students wearing laces?
Because I looked and I think that there's more.
That's interesting. Yeah, I'm not sure. Maybe I might agree with you on that, but I'm not sure. I'd have to double check.
Let's go by twos.
We could count by twos. That would be, is that something we could do?
Yes.
Oh,
Two, 4, 6, 8,
and one
one
left,
more is 10.
and one left over. Can we try it again, maybe by twos? Ready?
2,
4, 6, 8, and one makes
10.
9. Maybe we can count it by ones. Let's count it by ones.
1,
2,
3, 4, 5, 6, 7.
8, 9. Oh, okay. So there are 9. Okay, I'm gonna let's freeze. Free turn and talk. Because I don't want to give too much of the information away yet, because you're gonna talk to your friends. Hold on, Irene, stay right here. What was good about our turn and talk? Raise your hand if you noticed what was really great about Irene and I and our turn and talk. What did we do? Let's see. Yes, Maimuna.
You guys look at each other's eyes and you listen to each other's.
Did we look into each other's eyes? Yes. And did we listen to each other?
Yeah.
Yes.
And you guys are being nice to each other. You say, no, I don't want to play.
Right. Very good. Let's see. Is there anything else that someone might have noticed? Athena, did you notice something?
You were talking to each other very nicely and not saying that you don't want to talk to them.
Okay. So we were doing a good job being partners. Did Irene talk? Yes.
And you did too.
Did I talk too?
Yes.
Did Irene listen?
Yes.
Yeah.
And you listened to her.
And I listened too. Did we take turns?
Yeah.
Very good. Do you think you guys could do something like that?
Yes.
All right, so let's turn and face forward, and I'm going to tell you who your turn and talk partners are. Slide right over to here. And remember, when I tap you on your head, you're going to face each other, but you're not going to start your turn and talk yet, okay? So we're going to have Devon and Tori are going to talk. Wait a second. Okay, spin into each other. You're talking about what you notice. Do you think there's more students wearing laces or less students wearing laces? And I want you to talk about why. It's okay, Jimmy. Turn and talk to her. Okay, you can begin.
Yes, there's more. Yes, I think so.
Do you think there's more? Yeah. Do you agree or do you disagree? Do you think there's more students wearing shoelaces?
Do you think that there's...
Isn't that incredible? Kindergartners modeling the fishbowl turn and talk. I think sometimes as educators, we think students know what a successful turn and talk looks like, or and so we just, have them do a turn and talk, and then we're frustrated that they weren't talking about what they were supposed to be talking about. I just think taking this time to really identify what does a great turn and talk involve is very productive. All right, let's continue on. So our next mini lesson for building a math community is everyone's thinking is valued. Write a short story or create a cartoon strip that shows everyone's thinking is valued in math class. So again, we want to think about the age of your students. And again, we're sharing these, thinking about our kindergartners, but also all the way up to high school math. So of course, you're going to want to adjust this based on the age of your students. Students could do this independently or share with a partner, or they could work on this with a partner in a small group. These could be posted on the bulletin board or posted on a gallery wall. You can modify this again, like I just mentioned, for the age group you're working with. For kindergartners, perhaps providing scenarios and asking if it's an example of everyone's thinking is valued or not valued. For example, you could say, they were talking to someone and another person interrupted them. Is this everyone's thinking is valued or not valued? Or they were sharing in class and noticed that other students were looking at them and listening. Is this an example of everyone's thinking is valued or not valued? Our next one is practicing working with a partner with the Rally Coach protocol. So let's look over the directions. So students pair up together. One partner is going to be A, one partner is B. Partner A begins by solving the first problem, explaining their thinking and their reasoning and their steps aloud. Partner B is going to be in the coaching role and is going to actively listen, check for accuracy, offer suggestion, praises, ask questions, feedback. Then they switch roles. So we talked about this a little bit with your free gifts in the beginning. So they just keep going back and forth. You can give each partner pairs one of the Rally Coach cards that we shared with you. Next one, benefits of the gift of silence. Okay, so let's look over them. Number one, individual think time allows us to have something to talk about, or students. Number two, some people enjoy and need quiet moments. Number three, the gift of silence reduces anxiety because we can think through what we want to say. Number four, it allows us more time to process information. What you can do here is, and you might need to explain these depending on the age of your students, but then after you read these aloud and maybe talk about them for a few moments, you ask students to choose their favorite benefit of the gift of silence. That's also called wait time or think time. So you ask students to hold up their fingers. Is one your favorite? Is two your favorite benefit? Is three your favorite? Or is four? So they hold up their fingers. Then you tell them in the space that you're in your classroom, you designate, okay, this is corner one, this is corner two, corner three, and corner four. You tell students that they are to go to whichever they chose, that corresponding corner, and go have a discussion with the other students who are meeting in that corner about why they chose that benefit of the gift of silence. Then you could have them report out as that little small group, or you could have them go pair up with someone from a different group and share what they talked about, or you could have that group, each of the four groups, create a quick poster of ideas they shared. It's up to you. Lots of ideas for this mini lesson. The next one, we all bring something valuable to class. So on this one, we're going to use the turn the paper strategy. Okay, so here are the directions. In your small group of, again, we're really flexible in how you want to do this. Maybe it's 2 students, maybe it's 3 students, maybe it's a small group of 4 students. You don't want to have more than 4 though. Each group, small group, is going to need to create on maybe large construction paper or chart paper or poster paper. They could use 8 by 11. It could work. They're going to have to write smaller, but they're going to want to make a copy of what they see on the slide. So they're going to divide it into fourths. And in one of the sections, write, I am good at, I could teach someone too, I would like to learn, I want to improve. If your students are young and writing is going to take a long time and take up most of the time, it's not so important they write the sentence stem. They could just write the 1, the 2, the 3, or the 4. It's up to you. But what they do in the turn the paper strategy is each member of the group is going to need their own colored pencil or marker or crayon. So I might have red, the person sitting next to me has green, the person over there in my group has pink, whatever. And you're going to tell them how much time they have to reflect on that sentence stem, making sure. So I might first write in the first quadrant, I am good at. So you want to give them a little bit of that gift of silence to think about what they want to write about. And again, if writing takes a long time, maybe just have them sketch a picture. If they're a young student and writing is going to be cumbersome, they can just sketch a picture or a drawing. But the point is, you might put on some classical music or some soothing music, designate an amount of time. Maybe it's a minute, maybe it's a minute and a half, 2 minutes. And that's the time that each student has to write in one of the quadrants. Then you're going to have a gentle way to let them know, okay, that was your time in that quadrant. Now we're going to turn the paper and you'll put on the music again, set the timer again, and they write in a different quadrant. So again, we're focused on we all bring something valuable to class. At the end of the time, you might want to have them discuss out what they learned with the whole group or within their small group. Again, lots of flexibility in how you want to facilitate this. Here's our next one. We can learn from each other and teach each other. So on this one, the directions say, create a Venn diagram listing the benefits of teaching others and the benefits of learning from others. So again, this could be done with partners. It could be in a small group. You could keep it a whole group discussion and just have a large Venn diagram somewhere displayed in the room. And you want students to brainstorm what are the benefits of teaching others and what are the benefits of learning from others and where's the overlap in the middle of that Venn diagram. All right, here's our next one. Mistakes are valuable and lead to brain growth. So Jo Boaler, in her book, Mathematical Mindsets, states that every time a student makes a mistake in math, they grow a synapse. She also emphasizes that mistakes are valuable and can lead to brain growth. So on this one, turn and talk. Why is it important to have a healthy brain and attitude? Now, to support this one, we're going to share a video with you that you can share with your students. It is free and downloadable from the UCubed website, and that is Dr. Boaler's website. So she's put it out there for educators to use. So we're going to share it with you right now. And you think about, it's a 3-minute video. And we want you to think about, is it appropriate for your age group of students? Would it be helpful for them to see as you facilitate a discussion about math and brain growth? So let's go ahead and watch it.
One of the most exciting things I've learned in recent years that shocks most people I meet is this. When you make a mistake in math, your brain grows. Synapses fire in your brain. In fact, your brain grows when you make a mistake, but when you get work right, no brain growth happens.
When you make a mistake, you don't need to get the right answer. You just need to struggle and think about the mistake for synapses to fire.
That is because struggle and hard thinking are times when your brain grows the most.
This is why it's important in math class to work on hard problems that encourage you to struggle and even make mistakes, as these are the most important times for your brain.
Thomas Edison is a famous inventor. Over 100 years ago, he invented the light bulb, as well as many other important things. He allowed people to have light when it was dark, when previously they only had been able to use candles.
You may think he was just smart and probably didn't have to work hard, but that isn't true. In school, his teachers told him that he was too stupid to learn anything. Maybe that encouraged him more.
But it wasn't easy inventing a light bulb. He made 1,000 mistakes, but he didn't give up. He kept trying. When a reporter asked him how it felt to fail 1,000 times, he said he wasn't failing, he was taking steps. And he created something amazing. He is well known for saying this.
Genius is 1% inspiration and 99% perspiration.
There's a lot of evidence of the importance of mistakes in life too. It turns out that what separates the more successful business people from the less successful business people is that the more successful people have made more mistakes.
It is really important to take risks and take on hard challenges. Michael Jordan is a really famous basketball player. He was a
6-time NBA champion, the NBA scoring champion 10 times, and all-time leading scorer for the Chicago Bulls. The NBA's most valuable player 5 times, and he won 2 gold medals in the Olympics. Pretty amazing. This is what he said about his playing.
I've missed more than 9,000 shots in my career. I've lost almost 300 games. 26 times I've been trusted to take the game-winning shot and missed. I failed over and over and over again in my life, and that is why I succeed.
When experts have studied the difference between successful and unsuccessful business people, they have found that successful people do more of these important things. Try seemingly wild ideas.
Feel comfortable being wrong.
Are open to different experiences.
Play with ideas without judging them.
Keep going through difficulties.
are willing to go against traditional ideas.
All right, let's move on. Math is about communication is our next mini lesson. Independently list examples of how math is about communication, then compare and contrast your list with a partner. And again, this one can be modified to have students work in pairs, small groups. Maybe they share with another pair of partners or another small group after generating their examples. You could make a class list on a chart underneath. Math is about communication. Items that might be on the list: we talk and share strategies and solutions in math class. We draw pictures and visual models to represent our thinking to others. We use symbols and numbers and diagrams to express and convey ideas. We can write about how we solved a problem or the reasoning we used to think about it. We collaborate with others in pairs, small groups, and whole group. We might play math games, which involves communication. Next one up. Growth mindset means we can all focus on our efforts and our attention. List ways you can focus your effort and attention. List ways your focus and attention can get away from you. Compare your list with a partner. What do you have in common? What's different? To support this one, we have another free downloadable video. It's a 4-minute video from Dr. Bowler on mindset. So as we share it now, I want you to be considering, is this appropriate for your age level of students to view about mindset?
Hi, my name is Jo Bowler and I'm a Professor of Mathematics Learning at Stanford University. Welcome to the week of inspirational math that my YouCube team and I have designed for you. Most of the days start with a short video from my online course with some really important messages about math learning. And today's first message may be the most important of all. Everyone can do well in math. I hope you really enjoy the week. Here's the first video from the course. You may have been told or led to believe that some people are math people and some aren't, or that math isn't for you. Well, it turns out that's not true. Everyone is born with the innate ability to do well in math, and whether you do well or not comes from the experiences you've had and the beliefs that you hold.
Everyone can do really well in math.
There may be some people, who seem naturally good at math, or just love it, when you don't. But that has come about because of experiences they have had. Anyone can get to the highest level of math in school.
There's no such thing as a math person or the idea that some people are math people. Everyone is a math person.
Let's look at the brain evidence. Scientists now know that experiences grow your brain, and the brain is so plastic that it can rewire itself and grow in a really short space of time.
This is how learning works. When you learn something, a synapse fires in your brain. It's like an electric current. And the pathways formed by the synapse are like water in the sand. The more you return to an idea, the stronger the pathway gets. If you don't go back to it, it will wash away. When you learn something, your brain grows, and if you learn it deeply, it grows and stays. So you may think some people are just brainy or smart because they just are, but it all comes from what they've learned. And
you can catch up to them.
When you learn, synapses fire. And this doesn't just happen when you're in a class, it can happen when you read, when you build something, when you have a conversation, when you get an idea, and when you make a mistake. Synapses are firing in your brain every day.
The brain is like a muscle. The more you work the muscle, the more it grows, just like in the gym.
If weightlifters exercise with the same size weights, they wouldn't grow muscles, and they have to keep increasing the weights. It's the same with math. The harder you think, the more you struggle with an idea, the more your brain grows.
Here is some of the evidence that has stunned scientists in recent years and made them realize that everyone's brains can grow and change at any time.
Taxi drivers in London have to learn 20,000 streets and 25,000 landmarks in London before they become qualified. They study for 2 to 4 years, and at the end of that time they take a test which is just simply called the knowledge. When they've finished their training, scientists have found that the hippocampus in their brain is bigger. And the hippocampus is the area of the brain that's specialised in acquiring and using spatial information. When they retire from being a taxi driver, their hippocampus shrinks back down. That's how flexible the brain is.
Scientists took a group of people who could not juggle and split them in half. With one group, they really encouraged them to practice, also showing them some good ways to practice.
Not surprisingly, the group that practiced learned to juggle and the other group didn't. But the practice group also had significant brain changes. They grew the seeing and movement areas of their brains, and they developed more ability.
So the brain is much more plastic than anyone ever thought. In one of the studies, a 6-week training course, when students worked on a task just for a few minutes each day, changed the structure of their brains. And we should think about that. Working on a task for a few minutes per day for 6 weeks can cause your brain to rewire and grow. If that's true, imagine what you can do for your brain over the course of a year in a math lesson.
Fantastic video. Wasn't it great? All right, here's our next one. Questions are important. So partners for this one. Partner A, list why asking questions in math class is important. Partner B, list questions that could be asked in math class. Partners get together with similar partners. So have A's partner up with A's and B's partner up with B. So you're going to split the class in half. You're going to have half A's, half B's. And then next rotation, get together with a different partner. So A will compare with B and B will compare with A to share their list. Next up, math is about connections. In a small group, list examples of how math is about connections, or make a math connections web. Be as specific as possible. So again, depending on your grade level, you may want to swap out the image in the top right corner of this slide that's showing repeated addition and how it's connected to multiplication. You might want to switch it to something else. Students might give examples of the inverse relationship between addition and subtraction or between multiplication and division. Depending on your grade level, they might connect fractions with decimals or maybe fractions, decimals, and percents. And they might make connections with models, manipulatives, and equations. You might need to give them an example or two to get started. Oh, here's our next one. Depth of understanding is more important than speed. With a partner, write a brief description of what this means with examples. We have another video for you. This is another one from YouCubed from Dr. Joe Bowler, and it is free and downloadable, and it is 2 minutes long, so it's a short one, on the issue of speed in math class. Let's watch it now as you consider whether it's appropriate for your grade level or not.
Something else that's really important to know about math is that being good at math does not mean being fast at math. In fact, the opposite may be true. Mathematicians, who we could think of as the world's top math people, are some of the slowest math thinkers I've met. I don't say that to disrespect mathematicians. I work with many mathematicians, but they're not usually fast math thinkers. They're deep mathematical thinkers.
This is Lawrence Schwartz. He won the Fields Medal, which is the top math prize. It's like winning an Oscar in math. He struggled in school because his school valued speed, and he was one of the slowest math thinkers in his class. After he became very successful, he wrote an autobiography, and this is how he describes his school days.
I was always deeply uncertain about my own intellectual capacity. I thought I was unintelligent. And it is true that I was, and still am, rather slow. I need time to seize things because I always need to understand them fully. Towards the end of 11th grade, I secretly thought of myself as stupid. I worried about this for a long time. I'm still just as slow. At the end of 11th grade, I took the measure of the situation and came to the conclusion that rapidity doesn't have a precise relation to intelligence. What is important is to deeply understand things and their relations to each other. This is where intelligence lies. The fact of being quick or slow isn't really relevant.
Many strong mathematical thinkers, like Lawrence Schwartz, think deeply and slowly and like to understand things fully. If you are one of those people, do not be put off by people who may be faster. That isn't important.
What is important, to repeat Lawrence Schwartz, is to deeply understand things and the way they relate to each other.
It's fine, good even, to think slowly about math, and it is really good to think deeply and ask questions that will allow more depth.
Questions like, why does this work? How is this method connected to other methods? What would a drawing of this situation look like?
And it's important, if you're a slower thinker, never to think it means you cannot be a math person. It is great to think deeply and carefully, to fully understand, to ask questions. We need those thinkers in math.
Doing well at math is not about being quick or slow. It's about thinking about connections, thinking deeply.
Another great video. Wasn't that great? I know I appreciate it because I think I take my time in thinking about math problems. Just wanted to highlight for a moment some of Dr. Joe Bowler's books, which I found really useful and helpful. This one's called Mathish, Finding Creativity, Diversity, and Meaning in Mathematics. Oh, this was a great one. Limitless Mind. That was a really great one. And there's also, I have Mathematical Mindsets, another great one. She has a few others that I don't own, but those are good. And then her colleague at Stanford, who really began us on the pathway of growth mindset and fixed mindset, is Dr. Carol Dweck. And here we have Mindset. So I just wanted to share those. Those are great books, great resources. Okay, moving on. Math tools and visuals can help enhance our mathematical understanding. In a trio, brainstorm and list as many math tools and visuals used in math class that you can. Bonus points. List how that tool or visual helps with learning and sharing and thinking. Next one. Fair turns works out well for all. Make a T-chart of what a fair turn looks like and what it doesn't look like. Now we have another video on this one. We're going to watch an example of a teacher facilitating a discussion around fair turns. Our purpose in watching this video is to see how this could be done. And again, I want to ask you and invite you, what grade level do you think this will be before I push play?
Okay, let me see who is giving me a fair turn this morning. Fabulous. Everyone, thank you. When we do work in this classroom, we talk a lot about giving fair turns. We want to give fair turns. We want to get fair turns from our friends. So what does that mean to you when we say giving and getting fair turns? Devin, what does that mean? Like, what would you think someone would do for you?
Sit crisscross applesauce.
So sitting crisscross applesauce, Anna?
And be quiet.
Being quiet so you can hear. Aurora?
Be nice to people.
Being nice, of course. Sebastian?
And playing.
No playing. Oh, great. Selma?
Listening.
Listening. That's such an important one. Ida?
No hitting.
Right, of course. So when we're giving and getting fair turns, we're trying really hard to listen and show our friends that we're listening. Devin?
Pay attention.
Paying attention. That's exactly what a fair turn is. One of the ways that you can show people you're giving a fair turn and that you're really listening and understanding is by repeating what they say. So if you can tell somebody the words they said, then that person knows, boy, they were really listening to me. So today, when we're doing some of our math, and you guys are sharing your great thinking, I'm going to ask you to be able to repeat some of the things your friend said, okay? Does that sound good? Okay.
All right, so that was kindergarten, fair turns discussion. Our next one, being an active listener is important. With a partner, create 2 short skits, one that demonstrates great listening in math class and one that does not demonstrate great listening in math class. And again, this can be modified. Students could perform these skits or have them written down. Sharing could be done whole group, or 2 groups could share with each other. You know, it's really based on how much time you want to dedicate to this. Another idea would be to have half of the partners create an active listener skit and the other half create a non-active listener skit. So it's really up to you. Here's an active listening activity. So we need partners. Secretly, and both partners, so everyone in the class, is going to secretly create a picture drawing 2 shapes. So they're not going to don't let anyone in the room see what you did. Then they're going to partner up. Partner A is going to describe their picture without revealing it to their partner. So maybe they have a book up or something up to not show it. And then after they try to do their best describing how to draw those 2 shapes, then the other partner is really active listening, doing their best to try to draw it. And then they switch roles and then they reveal the pictures and compare. Now, again, there's so many modifications that could be done with this. It could be that students are doing a line of symmetry. So maybe they take turns and they'll pretend the line of symmetry is between them and they're trying to describe to their partner how to continue whatever the design was. So there's so many different ways you could practice this one. Next up, we will respect each other, our shared space, and materials. So have students, you could do this independently. Again, it could be with partners, could be in a trio or small groups, really up to you. Have students fold a piece of paper into thirds, so with 3 sections, and label each portion with one of these. Respect each other, respect our space, respect materials. And in each of the 3 sections, have students list how the class can show respect in that domain. Like, what will it look like? What will it sound like? What will it feel like? And have them give examples. Next up, math is about flexibility. There's more than one way to solve a problem. With a partner, list examples of how math is about flexibility. Hint, think about strategies and more. So for this one, you could provide a computation problem that's appropriate for your grade level and ask students to think flexibly about using multiple strategies to solve that problem. So maybe for 2nd grade, it could be 25 plus 14, and have students think about different ways to solve and know the answer to that problem and list. Next up, this is our last one. We're already at our 20th mini lesson. We are mathematicians. With a partner, list habits of mind that mathematicians have. Example, and you could share some of the examples if you think your students need help brainstorming or getting their creative juices going. Persistence, not giving up, explaining your thinking, working carefully. We hope you enjoyed those learning about the 20 mini lessons to support building a math community. Now let's talk about the gifts of facilitation handouts that you should have received in the email that also contained the link to this video. Talk moves. These are so powerful. So we've got reasoning, revoicing, adding on, wait time, or the gift of silence, repeating, and turn and talk. These can be a game changer for enhancing student communication during discussions. So we're modeling them, we're naming them, and we're expecting students to use these. Also, you should have received the Me Too hand signal poster or handout. And we use this one in class, and we share this with students. We post it as a reminder, that visual reminder, that when a student is sharing their thinking or strategy, and maybe another student in the class says, oh, that's what I was thinking too, or that's how I solved it. By doing this, now it's not a surfer. This is really sign language for I agree, me too. And it's the thumb. I teach my students the thumb to myself and then the pinky to the person that I was agreeing with. So it's a nonverbal way to let, excuse me, to let the teacher know that I was thinking the same thing. We also have the gift of silence. I do this one a lot when I'm working with students and I want them to know this is our think time. I'm not going to call on anyone. So I've just asked a question, but I'll actually go. Sometimes I move my eyes like I'm thinking. And it's just a way to remind them that I'm not going to be taking any answers right now. Remember, math is not about speed. So I'm honoring that students are processing and thinking at different speeds. So I'm honoring that time. This one is from this amazing book, Figuring Out Fluency in Mathematics. The authors had the idea that to teaching, this is also sign language for it is reasonable and it is not reasonable. So for an example, I might have up a problem like, or I might ask my students, is 600 is it reasonable or unreasonable as the sum of 50 plus 50? And so I'd have students show with their hands whether they think it's reasonable or unreasonable, and then talk to a partner, share out for the whole group. So we hope you enjoy these. This really can help the discussion and the thinking and the reasoning during math class go beautifully. Well, we're at the end of our time together. We want to thank you for your time and thank you for all you do for your students. We would love to have you join our future workshops. We've got kicking off kindergarten math, kicking off 1st grade math, 2nd grade math, 3rd grade math, fourth grade math and fifth grade math. You'll see on our website how to register for the link to watch the recorded videos. And of course, you will also get resources like you did with this workshop. We also have part 2 of those workshops we just shared. So keep it going in kindergarten math, keeping it going in first grade math, and so on up through fifth grade math. We also have amazing math routines. That is a workshop, procedural fluency and conceptual understanding workshop, rich task investigations workshop, fractions decimals boot camp workshop, math strategies versus algorithms workshop, and small groups, math centers, and games workshop. And we're always interested in creating more content that educators would find useful and helpful. So please shoot us an email or go to our website on the Contact Us page and let us know if there's a workshop you'd like for us to offer in the near future. We want to invite you to join our website or visit our website where we have many free resources for you to assist you in teaching your students math, including lots of videos from our YouTube channel. We have some free math games. We have a free math routine sampler and a lot more. And additionally, we offer in-person and virtual coaching and math workshops, as I mentioned earlier, for educators. So please let us know how we can support you. We hope you have a fantastic school year. Again, thank you for what you do and thank you for your time. Bye-bye.